Okay, we are continuing the examples for the review 7.1 through 7.6. This time, examples 36 to 43. So let's finish this out here. Okay, on example 36 here, we're going to start by trying to isolate the square root or the radical. And you'll begin that process by stripping off the lowest PEMDAS priority, which is that subtract 6, and you add 6 to both sides. Then you have to strip off that 2 that's on the outside, so we'll divide both sides by 2. At this point, you have the square root by itself, and now you square both sides, and your result is 144. And you have to check this by plugging it in to the original problem, and you can do that on your calculator. Okay, example 37. First, we have to get the radical, the square root by itself, so I'm going to take the negative 2x and take it over to the other side and add it. Then once you've done that and got the square root by itself, you square both sides, which erases the radical. A common mistake is to think that 2x when you square it is just 2x squared, but it's 2x times 2x gives 4x squared. So now I'm going to take my terms all to one side, and that'll give me the equal 0 that I need. You factor, set each factor equal to 0, and check. In this case, the negative 5 does not work. Okay, so we got one answer there, 1/4. All right, we're going to go on to example 38, and this one is very similar to your problem number 38. So I'm going to get the radical isolated. I'll subtract 14 from both sides. Then I square both sides. You'll see that show up on the next line there. Avoid the pitfall of just squaring the x and squaring the negative 14. You have to multiply the x minus 14 times the x minus 14, and you'll get a middle term of negative 28x. Bring all the terms over to make it equal to 0. Factor both sides, or factor the right side, and set the factors equal to 0. When you check, you find that one of the answers is extraneous, that 10 does not actually work in the problem. Okay, number 39, we're going to isolate the radical. You'll see me take a 3 over to the other side and make a minus 3. And as soon as I'm done with that, I'm going to square both sides. That gives the polynomial or the trinomial x squared minus 6x plus 9, if you do that right. Take everything over to one side and factor. And then you set the factors equal to 0 and check. Here the 2 fails to check. All right, example 40, where we have function notation here, and I have the definitions up at the top there of, well, it defines 3x minus 2 is what f of x is, and the other one is 3x squared plus 10x minus 8. Okay, and in example number 40, we have f minus g of x, which is f of x minus g of x. That's what that means. So you take the 3x minus 2 and take away the other one. Notice that I have parentheses around it because when you subtract, so you're subtracting all of it, not just the front part of it. The negative sign in the middle distributes, which causes this to be negative 10x and this to be positive 8. And then I collect your like terms to finish the problem. Okay, example 41 is f times g of 6. So that means f of 6 times g of 6. If you plug 6 in here, you'll get 3 times 6 minus 2 will be 16. And plugging a 6 into the other one gives 160. So when you multiply those, you get your answer of 2,560. Okay, now these definitions right here, right there and right there are going to be continued to be used down below. I just can't show them as I do it, okay? So, Goff of 5. All right, by definition, Goff of 5 is g of f of 5. In other words, we find f of 5, and that result then gets plugged into the other one. When you put 5 into function f, you'll remember it was 3x minus 2. You'll multiply 3 times 5 minus 2, and that's going to give 13. And then you take that result and plug it in the other one. And let me go back up there and you can see that definition. Here's the one we're working with. So we're going to plug into that one. And when you do all the number crunching in this thing, you end up with 117. Okay, the last one here is example 43, and it's fog of x. And with fog of x, you're going to take f of g of x. That's what it means. So we're going to put g of x inside. And you can see I copied that function we had at the top. And then I'm going to take that and plug it into the other function. And so that trinomial is going to take the place of this x. So we're going to stick that trinomial in where that x is. And you'll see it here in a minute. You'll triple it and subtract 2. Distribute. And collect your like terms to finish it up. And that does it for problems 37, I think. Let me go back up there. I've forgotten which one it is. 36 to 43. Hope that helps you.